Hello guys, can you hear me? Is everything fine? I think my voice was low. Now it's fine. It should be fine. Okay guys, how was your contest today? Did you have a good contest today? Hi. Good. I also solved from A to E and we'll solve F as well in the live stream. We'll talk about F as well. So, okay, shall we start? Bad contest it was? Oh, I see. Oh, that's bad. Okay, so let's start talking about the problems, and I hope that you will enjoy this live stream as well. So let's start talking about the first problem. Problem A. Let me bring it. So you should be able to see my screen now. Yes, you are. Let's wait for a second. Okay. So the first problem says that Monocarp visited a retro arcade club with arcade cabinets. They got curious about the cash the coin cabinets. You know, the whole point is that there are several coins and the coin number I is at points xi and yi, and Monocarp starts from 0 and 0 and wants to catch one of the coins. Each time it can go to any point that is adjacent to it, and adjacency is considered, xy is considered adjacent to 8 points. X and y plus 1, x plus 1 and y plus 1, x plus 1 y, x plus 1 y minus 1, and so on. Okay. But each time when he goes through to the side of that point, after that all the coins, their value of y will be decreased by 1. So all of the coins will fall down afterwards, after that Monocarp has done his move. You have to say that at the end, what is the at the end, if it wants to catch only one coin, what is the minimum? Oh no, sorry, no, not what is the minimum. How many of the coins? For each coin, you have to say that if it can catch that coin, if he can catch that coin or not. Okay. So this is all we say. So basically, this Monocarp starts from one of the points like this. Let me change. So Monocarp starts from 0 and 0, and there are several coins. Each coin is at some place, and each time it can go to one of the adjacent points, one of these 8 points, and then afterwards everything will fall down. All the coins will fall down. But first of all, the first thing that I say is this: instead of assuming that all the coins will fall down, you can just say that, you can just assume that the Monocarp himself will go upward. That's the same, right? So what I say is that instead of assuming that afterwards all the coins will fall down, I just say that, okay, all the coins stay at the same place, Monocarp himself will go upwards. That's the same, I mean the relative distances to all the coins remains the same. It's like you have shifted the grid upward. Okay, so we can assume that each time Monocarp goes to the side of one of the coins, and afterwards he will go only 1 point upward. Okay. And if you consider that, then you can easily see that Monocarp can reach any point such that its value of y is greater than or equal to -1. Because initially the value of y for Monocarp is 0, and each time first it can decrease it by 1, but afterwards y will be increased by 1. So it can never go below y equal to -1, but it can reach -1 and above. Therefore, we can say that it's only possible if and only if y is greater than or equal to -1. Does this make sense? If you're okay with that, please use this emoji. And if you have any questions about it, tell me too. I also show you my code. The code is also very simple. You can see the code here. I just see in x and y, if y was greater than or equal to -1, see out yes, else see out no. That's all. Shall we move on to problem B? Okay, I'll explain it again. If you didn't understand, I explain it again. I'm just saying that assume Monocarp, instead of saying that Monocarp doesn't move and afterwards all the coins will fall down, assume that Monocarp himself will go upward. So instead of saying that all the coins will fall down, let's shift the whole grid upward. So it's like all the coins remain at the same place, but Monocarp moves one point upward. So instead of assuming, this makes the problem a lot simpler if we assume that Monocarp himself will move upward instead of assuming that all the coins will fall down. So each time Monocarp goes to a direction that he chooses, and then afterwards he has to move upward once after going to that direction. And this way you can show that y can never become less than -1, because each time Monocarp can decrease his y by at most 1, but afterwards its y will be increased once again. So y can never be less than -1. Therefore, x and y, a coin at point x and y, is reachable if and only if y is greater than or equal to -1. If it is so, Monocarp can reach there, even though he has to move upwards after each move. Otherwise, if y is less than -1, there's no way. You can see that the position of this coin will always be below the position of Monocarp, and Monocarp can never reach that point. Is it clear now? Okay, so this is the whole thing about this problem, and you can also see the code here. So I see in x and y, and then see out if y was greater or equal to -1, yes, otherwise no. Is it clear now? Okay, great. So let's move on to the next problem, problem B. Problem B states that you are given two strings A and B, both consisting of lowercase Latin letters. A subsequence of a string is which can be obtained by removing several characters from the original string, a subsequence. And a substring is a continuous substring. A substring is a continuous subsequence. So you have to say that you are given A and B, you have to find the minimum possible length of a string that contains A as a substring and B as a subsequence. Okay, so we are all aware of the aware of the definition of substrings and subsequences. A subsequence does not need to be continuous, but a substring has to be continuous. That's the only difference. Okay, a subsequence is does not have to be continuous, but a substring is a continuous subsequence. Is a subsequence that is that must be continuous. So you are given A and B, and you need to find out what is the minimum possible length for a string, for example S, such that contains A as a substring and B as a subsequence. Well, what I say is that first of all, we know that A should be somewhere in S. Okay, A should be somewhere in S, right? Now I can say that for B has several characters, that one of them, for example, is here, one of them is here, one of them is here, one of them is here, for example, and one of them is here. So these blue cells are for B are subsequence of the string S that is equal to B, and this red interval is A. Well, my point is this, is that it's like an interval of B lies inside A. Okay, so if this is your A and this is your B in your string, I'm saying that an interval of B's lies inside A. Okay, an interval of B's lies inside A. Now I want to fix the start of that interval. So I'm saying that one of the letters are inside, and my final answer is going to be size of A plus size of B minus the number of elements in here, minus the number of shared elements, the number of elements B that lie in the interval of A, minus this value, let's call it X. Okay, so that is what I'm saying. I'm saying that the answer is length of A plus length, because before that there's no need for additional characters. We can just have these characters that are in B, and after that we don't need any additional character as well. We can just consider that we have these characters for B, and only those shared ones will be counted once instead of twice. So each letter should be either from A or from B. Those shared ones can be counted only once, so we can subtract them. So we want to maximize the number of shared ones. Okay, tell me if any part of it is not completely clear. So we want to maximize the number of the shared ones. And how can we say that? The point is, now my question is this, to find the value of X, which means that we have some value A, some string A and some string B, and we want to find the maximal interval of B such that it appears as a subsequence in A. So in other words, I'm saying that I want to find an interval in B, a substring of B, or an interval of B, for example, it is these letters, such that these letters are as a subsequence of A, like this. For example, those 4 characters will be here. Then we can match them together. We can match this character with this character, this with this one with this one, and this one with this one. So we want to find the greatest interval in B such that that is a subsequence of A. Okay. Now what I say is that I will fix the start of this interval in B. Okay, I will fix that. What is the start? I have a 4 on B. I fix the start. Now it's like when I cut the ones before that, I can just use a pointer then. I have a pointer in here and I want to move it forward as much as we can. I iterate over A each time. If this letter matches with this pointer, I will move this pointer forward. So the point is, when I fix it, then a prefix of B, let's call it B prime. Let's fix the first character of that interval and remove the previous ones and call that B prime. Now a prefix of B prime should be matched with A. And when a prefix of B prime should be matched with A, we can just keep a pointer and just have a for I from 0 to A dot size, and just say that if B prime or B of that pointer was equal to A of I pointer plus plus. Okay. So that's all we want to do. We fix the starts of that interval in B. We want to maximize, we want to find an interval of maximum size in B such that that interval appears as a subsequence in A. Now I'm saying that let's fix the start of that interval in B. Let's fix the start of that interval in B and let's put a pointer there. Let's put a pointer there and then start iterating on A. Each time, if that letter matched with the corresponding letter in A, move that pointer forward. If not, just ignore that letter of A. Okay, so let's consider an example. Yeah. So, for example, let me find a good example. Yeah. For example, in the samples, consider the last query. A is C, D, E. B is A, B, C, E, F, G. Okay. In here, I want to find, I'm saying that the answer is length of A, which is 3, plus length of B, which is 6, minus the maximum possible shared elements that I can have. I should find an interval in B that is a subsequence of A. For example, in this example, if we fix C and E as the interval of B, we should choose an interval of B that is a subsequence of A. C can be matched with C here and E can be matched with E here. So two elements can be matched. An interval of B appears as a subsequence of A. So these can be matched with each other, right? So, and this is the maximum possible, so it's -2, which is 7. So how do I find that? How do I find the maximal size of a substring? How do I find the maximum size of a substring of B that appears as a subsequence in A? Well, I can just say that I fix the start of B. Let's write this example here again. C, D, E. So my question is not trying to find this X, the maximum size of an interval of B that is a subsequence of A. C, D, E, A, B, C, E, F, G. If I start from here, if my interval starts from here, I see that my interval should be empty because it starts with A and A cannot be matched with anything in the first string. So there's nothing we can do. If I start from here, the answer is 0. Sure, I will explain that example as well. If I start here, again, there's no way that I can match anything. So it's 0. If I start from here, when I iterate over this, I see that this C matches with this C. So I move pointer forward. And then I see that this D is not equal to this E. So I don't do anything, I ignore this D. And then I'm on E and I see that E matches with this E. So again, I move the pointer forward. So the pointer will be forwarded, will go forward twice. So in here, the answer is 2. I can move pointer forward twice. In here, if I start from here, I see that it doesn't match with C, so I don't do anything. It doesn't match with D, so I don't do anything. It matches with this E, so I move the pointer forward. I move it forward only once this way. So in here, answer is 1. If I start from here, F does not match with anything, C or D or E, so the answer is 0 from here. If I start from here, G does not match with anything, so it's 0. And my final value of X is maximum of all these starting points, 0, 0, 2, 1, 0, 0. For each of these starting points, I calculate the answer and I find the maximum value of them. And that's going to be my final answer. We can't do LCS, no. Because, you know, what does LCS say? LCS is, let me say it like this. LCS is the greatest, the longest, it's better to say the longest string C that appears as a subsequence in both A and B. This is the definition of LCS, right? But what is the question that we want to solve? Our question is this. We want the longest string C that appears in A as a subsequence and in B as a substring. So the difference is that our question is this. Our question is we want to find the longest string C such that C is a substring. Let's first say subsequence of A is a subsequence of A and a substring of B. Okay, so this time I want to find the longest string such that is a subsequence of A and a substring of B. LCS says that subsequence of A and subsequence of B. But here we want to find the longest string that is a substring of B and the subsequence of A. Because we said that at an interval of B should be matched with a subsequence of A. In LCS, we match a subsequence of B with a subsequence of A. This is LCS. We match a subsequence of B with a subsequence of A. But in our problem, we said that we should match a substring of B with a subsequence of A. Because if we can do that, because then we can just say that we can have A in the middle of S and all the remaining characters of B in here and all the elements to the right of that in B to here. And then this string contains B as a subsequence and A as a substring. So this is the difference that this problem has come to LCS. Does it make sense now? If so, I can also show you my code. Minimum as length of A and stores in map and the... Thank you. Yeah. So, do you have any questions about it? Shall we talk about the code? Yeah, sure. I will also explain it to you using my code. Well, in my code, as I said, I want to find the longest substring of B that matches with the subsequence of A. As I said, I fixed the starting point in B. I see that from where do I start in B. And I want to match this interval with a subsequence of A. I fix the starting point, PTR is equal to this SC. And then I have a for I starting from 0 and go to A dot size. And then I say that if PTR was less than B dot size and this character of A matches with that character of B, move PTR forward. Because in B, I should start from SC. I know that I should start from SC. And I cannot skip any character. Because I cannot skip any character, I can just move PTR forward one by one. So I won't do LCS this time, because this time I have an additional constraint that I cannot skip any character on B. I cannot pick this one, skip the next one, and pick the other one. So my PTR can be initially SC, and it should go forward one by one. So each time when it matched with the letter of A, I can move that forward only once. And at the end, my answer will be maximum of the current answer and A dot size plus B dot size minus PTR minus SD. So assume that this is in a parenthesis, is PTR minus SD, because the length of these matched parts is PTR minus SD, because PTR is the end of that, SD is the start of that. PTR is the first one that is not in that interval. So it's going to be A dot size plus B dot size minus PTR plus SD. Does this make sense now? If you want to send your code, I encourage you to join our Discord server. There you can send your code. All of you guys are welcome in our Discord server if you want. Okay, if it is clear, please use this emoji again. And if you are enjoying the live stream so far, I would appreciate it if you liked the video as well. I think that would help. Thank you guys. Great, awesome. Awesome, if this is clear, then let's move on to problem C. I use atom, this ID. I use this ID, atom. Okay. Oh, you didn't see, sorry. I didn't share my screen. Did I? Okay, what I'm seeing is just before the real live stream. Okay, let's talk about the next problem. A movie company has released 2 movies. These 2 movies were watched by M people. For each person, we know their attitude toward the first movie and towards the second movie. If a person asks to leave a review for the movie, then if likes, increases that rating by 1. If doesn't like, decreases that rating by 1. Otherwise, it has no effects. And there are 2 movies, and each person has some attitude about each one of them. You want to choose that for each person, which review of which movie you want to ask from that user. You have to choose exactly one of the movies for each of the users, such that at the end, the minimum of the ratings of the 2 movies will be maximized. And you always should choose one of them at least. For example, in here, when there is one person and it says -1 about both of the movies, you should assign it to one of the movies, and the answer is -1. So each person has, let me explain to you in an iPad. So each person has some attitudes. For example, has AI about movie number 1, BI about movie number 2. And you have to choose one of them, and if you choose the first one, the rating of the first movie will be increased by AI. If you choose the second one, the rating of the second movie will be increased by BI. And you have to maximize the minimum of the ratings of the 2 people. Okay. So the first fact that I want to say is that if a of I is not equal to b of I, for sure we will choose the one which is greater. If, for example, ai, without loss of generality, assume that a of I is greater than b of I, then I'm saying that for sure that person will should be assigned to the first movie. It's always beneficial if we assign that person to the first movie, if a of I is greater than b of I. Why? Because the ratings are 1, 0, and -1, right? The ratings are 1, 0, and -1. And if a of I is greater than b of I, there are three cases. If ai is 1 and bi is -1, I mean, why you should ask the review of that person for the second movie? Why you should decrease the review of the rating of the second movie and also lose the opportunity to increase the review of the first movie? I mean, if someone is like this, if you choose the first one, is definitely better than the second one, because the rating of both the movies will be increased by 1. The second one will not be decreased by 1, and the first one will be increased by 1. Also, if ai is 1 and bi is 0, if you choose the second one, you had no effect on the second one anyway. So you could, in fact, instead of this, just choose the first one, and that wouldn't make any harm, because b of I doesn't change as well. B of I is 0, so the second movie, nothing changed for the second movie. Only for the first movie, its rating will be increased by 1. So it's better if you choose the first one. Also, if a of I is 0, and b of I is -1, again, why you should choose bi? Why you should decrease the rating of the second movie? Okay, so because the ratings are in the range from -1 to 1, it was not true if the rating could be anything. If, for example, if the ratings could be from -5 to 5, this was not true. But because the ratings are from -1 to 1, you can say that definitely you will always choose, if ai is not equal to bi, if ai isn't equal to bi, you will definitely choose the one that is greater. If ai is greater than bi, you will ask the review for the first movie. If bi is greater, you will ask the review for the second movie. So our question is only for the case that ai and bi are equal. The rest of them are trivial. Is it clear so far? Please show me this reaction if it is clear so far. If we could choose from -5 to 5, for example, it was possible that we have, for example, 10, let's say it like this. If it is from -5 to 5, we could choose, we could assume that the first player is 5, the first user gives ratings 5 and 0, the second user gives ratings 5 and 4. Okay. In this case, it was optimal to choose this 5 and this 4. If the ratings were from -5 to 5, it was optimal to choose this 5 and this 4. Then the maximum, the minimum of these two movies will be 4, and this is maximized. So if the numbers could range from -5 to 5, this fact wasn't true, that if they are different, you should choose the greatest one. But because they are 1 and 0 and -1, the fact is that their signs are different. 0 is neutral and -1 and 1 have different signs. So because they have different signs, it's like you are either giving benefit to something, to some movie, or you are harming the other movie. I mean, your choice, or you're neutral about the other movie. So the fact is that if you choose the other movie, it won't be better. It's not like you can benefit both of the movies if AI is greater than BI and you want to choose which one to give benefits. You always help something and harm the other one. So because of that, because their signs are different and they are like this, that this is gonna work. And also, even if the range was from, for example, from 5 to 7, if the range of the ratings were from 5 to 7, again this fact was true. If the range, I'm a bit talking out of topic of the problem. I'm just solving the harder versions of the problem. I'm just saying that if if the range was from 5 to 7, that was still true, because you could just assume that the final value is n is, for example, 6n already for both of them. I guess no, it doesn't work. Sorry. I wanted to shift everything, but that doesn't work. So yes, it only works if they are from -1 to 1, because their signs are different in this case. Okay. So I'm sure about the ones that are different. I'm done with the ones that are different. But about the ones that are equal, well, first of all, 0 does not matter, so I can ignore the zeros. There are two types, positive ones and negative ones. And how can I say them? I can just do a brute force. I can calculate it in O of 1 as well. I mean, I can use mathematics and solve that in O of 1, but that is not needed, because there are n of them in total. So I can say that, for example, assume that this is the number of these is, for example, x, the number of these is y. I can say that while x minus minus increase the minimum of them. For example, if the rating of the first one is less than rating of the second one, r1 plus plus, else r2 plus plus. So I'm doing simply brute force. I'm just seeing that which one is less than the other one. I'm increasing the one that is less than the other one. And then I say while y minus minus, I will decrease the maximum one. Again, I'm saying that you can also solve it in O of 1, but in the contest, I was like, why I spent time to think about that, while they are at most n, and I can simply just write a while and find the answer. So I didn't at all spend time on the mathematics to write it in O of 1. I just say that if r1 is less than r2, r1 plus plus, in here, if r1 is greater than r2, r1 should minus minus, else r2 minus minus. Okay. Is it clear? Yes. For O of 1, you can consider that ratings, they have some initial rating, because we said that if AI is not equal to BI, we give that rating to one of the people, to one of the movies. So they have already some ratings. We have some R1 and R2, and also we have some X and some Y. Well, the point is that if X plus Y is greater than or equal to R2 minus R1, assume that R2 is greater than R1. Otherwise, we can swap them, right? If this was greater than or equal to this, then we have enough operation to make them almost equal. Why do I mean by almost equal? I mean that either equal or their difference will be 1. Okay. If x plus y was greater than or equal to r2 minus r1, we can make these two numbers almost equal. And it's always optimal to make them almost equal. If their sum is odd, we have no choice. We should have one difference between them. But if the sum of them is even, we can make them exactly equal. But if x plus y is less than r2 minus r1, then the answer is r1 plus x. We can do these decreasing operations from r2, all from r2, and these increasing operations all to r1. So if their difference was greater than x plus y, you can just say that r1 plus x. The answer is that. If x plus y was greater than or equal to r2 minus r1, you should make them almost equal. So the answer is going to be R1 plus R2. That's me. The answer is going to be R1 plus R2 plus X minus Y divided by 2. Because the sum of the two ratings will be this at the end, I should calculate the floor of this value divided by 2. So yes, this is of one solution, but in the context I didn't want to spend this time to think about finding this. I just said that, okay, n is small, so let's do brute force and find that out. Is it clear? So the whole point is that if x plus y is greater than or equal to R2 minus R1, we can make them almost equal. But if x plus 1 is less than R2 minus R1, we cannot make them equal. I mean, even if we do all the addition operations to R1 and all the decreasing operations to R2, they will not be equal. So at the end, the ratings will be R1 plus x and R2 minus y. And the minimum of them will be R1 plus x. Okay. Yes, I will now show you my code and also show you an example. Let me first show you my code. Well, first of all, as I said, V1 and V2 are the ratings. SP is the number of positive ones. SM is the number of negative ones, minus ones. So I say that if A of I was greater than B of I, as I said, I should increase V1 by AI. If B of I is greater than A of I, again, as I said, I should increase V2 by B of I. If they're different, it's obvious that which rating we will consider. Else, if A of I was 1, I will increase SP by 1, because the number of positive ones will be increased by 1. If it was minus 1, SM plus plus, and if it was 0, just ignore it. It has no effect. If AI and BI were both 0, just ignore it. And then I just say that while SP minus minus, as I said, I here use just brute force to find the answer. I could also use this math that I showed you here. I could also use this math. But it is not even necessary, because the number of x and y, x plus y, is at most n. So even if I do a while, that would also work. So I just say that while SP minus minus, if V1 was less than V2, V1 plus plus, else V2 plus plus, and then while M minus minus, if V1 is greater than V2, V1 minus minus, else V2 minus minus, and at the end, COT minimum of V1 and V2. And that's gonna be all. And as you said, yes, I can show you an example. For example, if you consider this one, if you consider this example, well, let me. So in this example, in here we have minus 1 and minus 1. So SM will become 1. In here we have minus 1 and 1. So definitely I should choose this one. Why should I choose the first one? To decrease the rating of the first movie, and also do not increase the rating of the second movie. So the rating of the second movie is 1 so far. Then again in here also I will choose the second movie. So the ratings are so far 2 and 0. And we have 1 negative 1, and we have 1 positive 1 that we can choose to add to any of them. I have 1 negative 1. I see, first I add this positive 1. I want to add this positive 1. I see that which one is smaller than the other, and I will add that one, because that one needs it more. Because minimum matters. So I want to make them as close as possible. So I will add this one by 1. Then I want to do this minus 1. I see that which one is greater. I see this 2 is greater, so I decrease it by 1. So this way I can say that at the end my ratings will be 1, and 1 minimum of them is 1. So this is going to be my final answer. Is it clear? If you're okay with that, please again use this emoji. Thank you very much, guys. Yeah, I'll be very happy when I see that you like this stream and the solutions. Okay. Okay, let's start D. Okay. Problem D. Smithing skill. What was this problem saying? Okay. So in this problem, it says that we want to make some weapons and we should use metals to make those weapons. And you have several different types of metals. Each time you can choose one of the metals, and in order to create weapon number I, you have to use A of I of that metal. You can choose any type of metal, and you should choose AI unit. You should use AI unit of that metal to create that. After crafting the weapon, after making the weapon, you can just melt the weapon again to get back to return BI units of that metal again. You need to find out each time your experience, each time that you create a sword or you melt a sword, your experience will be increased by 1. You have to say that what is the maximum possible experience that you can get. Okay, so this is the problem. N and M are up to 10 to the power of 6. AI is also up to 10 to the power of 6, which is very important. And CIs are up to 10 to the power of 9. Okay. So, we know that, based on what we saw, we know that sword number I gets AI when we want to craft it. And when we melt it, gives back BI. BI is definitely less than AI. Well, so there is a condition to use this, to make this, to create this sword. And we know that each time when we create a sword, when we craft a sword or we craft a weapon, we will definitely melt it again because there's no harm in melting it. It's not like we cannot melting it. There are no requirements for melting. It will just increase our metals. So definitely, each time when we craft a weapon, right after that we can melt that again. There's no need to keep it like that. So each time we create a weapon, we craft a weapon, and then right away we will melt that again. Okay, so each time we first craft and we will melt right again. Okay, and assume that I want to use metal number J. What is the condition that I should have if I want to craft metal number I and then melt it right away? C of J should definitely be greater than or equal to AI. Otherwise, I cannot craft the weapon at the first place. Okay, if C of J is not greater than or equal to A of I cannot craft the weapon in the first place. Also, after crafting and melting again, C of J will be decreased by AI minus BI. Right? So first, the requirements of creating a sword is that C of J should be greater than or equal to AI. And the effect of that is that C of J will be subtracted by AI minus BI. And we will gain 2 units of experience afterwards. Well, there are several facts that I can use now. Let's sort all the weapons by their value of AI. Let's sort all the types of weapons by their value of AI. I'm saying that if we have 2 swords like I and J, such that AI is less than AJ, and also AI minus BI is less than BJ minus AJ, then I can say that the second sword is redundant. I will never craft the second weapon. I will never craft the second weapon. Why? Because if I have the requirement to craft the second weapon, well, instead I can also craft the first weapon because its requirement is even less than that. And also its effect is better. C of j will be decreased by ai minus bi, which is less than aj minus bj. Okay, so both its effect is better and also its requirement is lower. And if we can craft the second sword, the second weapon, we can also craft the first one. Okay, so in this case the second sword is redundant and we can ignore that at all. We will never craft that second sword. Okay, does this make sense so far? Please use this emoji if this makes sense. So the first fact that I said was that if I have two different swords, two different weapons, such that the first one, for the first one, the value of A is less than the second one. No, the return on the first one is better. Because the return is, I will lose AI minus BI of metal after that. Okay. We will lose AI minus BI of metal. So if the requirement is lower and also what we'll lose is lower, it's always better. It's like weapon number I will dominate the weapon number J. Weapon number I is strictly better than weapon number J in any sense. Because when I can do weapon number J, I can also do weapon number I, and also its return is better. I will lose less metal. So this way I can say that this is redundant. So at the end, if I remove those weapons, I will have a set of swords in the sorted order such that the values of AIs are increasing and the values of AI minus BI is decreasing. The last sword has the greatest requirements but has the best return. Okay, the last sword has the best return, but the point is that its requirement is high, so I cannot always use that. And the first sword has the lowest requirement but has the worst return. Okay, so this is how it's like a trade-off now between these two, the requirements and the return. As you go forward, the requirements will be greater but the return will be better. Okay, these are the best weapons that I might use. I will be left with these swords. And in the worst case scenario, all of them can remain. Because maybe it is possible that all of them will remain. Okay. For example, if I want to tell you how I can say that well, it is possible that, for example, AIs are from, for example, n plus 1 to 2n, and this one has the worst return, has the worst return. These are, for example, all the odd numbers, 2n minus 1. In this case, if these are BIs, these are BIs, these are AIs. Then AI minus BI is n minus 1 to 1. Okay, so it is possible that all the swords will remain at the end. So we're gonna have a set of swords such that all of them are useful now. There's a trade-off between the requirements and the return. The requirement might be greater, but the return will be better in that case. Now we need to focus on a very important constraint, and that is this: AI is up to 10 to the power of 6. We're gonna really use this. Why? I said that first, let's assume that CIs are also up to 10 to the power of 6. Assume that for now, assume that CI is up to 10 to the power of 6. as soon. Okay, then I will write a dp of I such that dp of I is the answer if if we, from a metal we have I unit of that metal, what is the maximum number of swords that we can craft and then melt. Okay, let's show that with dp of I can say that for dp of I, my answer is going to be I should see the latest possible sword that I can craft with I. So I should do a lower bound. Assume that all these swords are stored in a vector. I should have a lower bound on the vector and find the first one. First, find the latest one that I can craft it. And then, if for example that is its value, if for example it is the weapon number J, it has some value of AJ and some value of AJ minus BJ. Then I can say that dp of I will be equal to is obviously optimal to use that sword, because I can use any sword from sword number 1 to sword number J, from weapon number 1 to weapon number J. I can use any of them. But the best return, I mean after the operation, the maximum amount of metals that I will have is I minus this value, because this one will use the minimum number of metals. It will lose the minimum number of metals. So dp of I will be equal to, if the latest one in that vector is J, dp of I will be equal to dp of I minus AJ minus BJ plus 2. Because I can craft the sword number J and then melt it again. I can craft the sword number J and then melt it back. And then afterwards I will have these many units of metal afterwards. Is it clear? What is J? What is the value of J? J is the latest weapon. J is the last weapon that A of J is less than or equal to I. So it means that if I have I units of metals, what is the greatest sword that I can make? What is the greatest weapon that I can make? I said that I have a vector in which I just keep the best swords. And I said that in them there is a trade-off. As much as A grows larger, the value of AI minus BI will be lower. Because I removed the redundant ones. I removed a weapon if there is another one such that it uses less value of A and it has less value of AI minus BI. So all the remaining ones, if they are good, it means that all the previous ones were losing more metals than this one, right? Now I'm saying that let's find this weapon number J, the last weapon. I'm saying that this weapon is the greatest weapon that I can make, and it is the best one. Why it is the best one? Because it loses the minimum number of metals between all the weapons in the first J weapons. Because I said that now with the remaining swords, I removed several swords, and now I have some remaining weapons. In these weapons, I know that if I create a greater weapon in these remaining swords, let me use this color. If in, okay, it didn't work. No worries. In the remaining swords, in the remaining weapons, if I craft a greater weapon, I will lose less metal. Okay, so in the remaining swords that I have, if I craft a greater weapon, I will lose less metal. Because if there is another sword which is smaller than this weapon, but it would lose less, this one was redundant and I would remove it. So in the ones that I haven't removed, such a sword does not exist, such a weapon does not exist. Right? So I'm saying that the greatest weapon loses the minimum value of metal, the minimum possible value of metal. Therefore, I can say that I just craft that one and melt it back. What happens if I craft that one and melt it back? I will lose this much, aj minus bj, which is minimum in the first j values. This is the minimum value of a minus b. I will lose this much, so my dp is going to be this dp plus 2. And that 2 is because I'm crafting and then melting back. So there are 2 operations for that. Is it clear now? Shall we move on to the code? Is it clear? Okay, so let's move on to the code. Well, about the code, first I seen everything, and then IOTA just puts values from 0 to n minus 1 in the first n cells of ORD, and then I sort ORD by CMP. In CMP, I sort them if the value of A is less than in the first one than the second one. So in ORD, or if I consider ORD, it is an order on the swords such that the value of A will be increasing in them. Okay, the value of A will be increasing on them. So when I have a 4 on all these swords, now I'm on sword number I. I is equal to ORD of T. So I'm on this sword I, and then I say that if vec.mp, vec is going to have all the good swords. Okay, in vec, I will keep all the good weapons, the good ones. I say that if vec was empty already, or this weapon, I know that this new weapon that I'm adding will require the maximum number of metal, the maximum amount of metals. So it should lose minimum amounts among the previous ones if it's gonna not be redundant. So either vec should be empty, or this one should be ai minus bi should be less than vec.back.second. Vec.back.second means that how much the last one loses metal. The last one is the minimum value that will be lost, right? I mean the last one that is in vector has the minimum possible amount of metal that it will lose. Because I said that between all the swords that are good, their value of A's are increasing, and the values of AI minus BI, how much we will lose, will be decreasing. So the minimum will be the latest one. If this one was better than the latest one, then it is useful. Then I can say vec.pushback AI and AI minus BI. It means that it requires AI and it will lose AI minus BI. And then, and I didn't say something that I will tell you now. Because I solved a problem for the case where CI is up to 10 to the power of 6. I will tell you now how to handle it when CI is up to 10 to the power of 9. So first, let's talk about up to 10 to the power of 6. I say that I have a pointer, I will increase it by 1 as long as I want to solve dp of I. I will increase ptr until it should be less than vec.size, and also vec of ptr dot first should be less than or equal to I. I mean, I should see the amount of metal that it requires should be less than or equal to I, because I have I units of metal. So vec of ptr.first should be less than or equal to I. While that was true, I will increase ptr by 1. And then at the end, if ptr minus 1 is the latest one that I have passed. The latest one. Each time, if vec of ptr.first is less than or equal to I will increase ptr. So ptr minus 1 is the latest one that is less than or equal to I. Vec of ptr.first is less than or equal to I. So I can make that sort. Then I said dp of I is equal to dp of I minus vec of ptr minus 1 dot second plus 2. Because I will lose this much, and then afterwards I will earn 2 experience, 2 units of experience. Okay, so is it clear so far? Yes, constraint of C is up to 10 to the power of 9, and I will tell you now how I can fix that. Now, if Ci was greater than, I know that Ci is up to 10 to the power of 9, right? So I just say that when Ci is up to 10 to the power of 9, up to 10 to the power of 9, I say that if C of I was greater than the value A of the latest weapon, for example, let's call that A of K. Let's say that there are K good weapons left. They are A1 to AK and AI minus BI to AK minus BK. I say that while C of I was greater than A of K, I can just keep using the last weapon. I know that A of I's are up to 10 to the power of 6. So A of K is also less than or equal to 10 to the power of 6. Then I can say that while C is greater than 10 to the power of 6, 10 to the greater than AK, I can just keep subtracting it by the last weapon. Okay, so if it is greater than AK, I can just continue using the last weapon many times, crafting the last weapon many times until C of I becomes less than AK. Okay, so what I say is that in that case, I just first add to ans Ci minus vec dot back dot first divided by vec dot back dot second. These, I can have these many steps. Okay, if I do these many steps, and I only do that if C of I is greater than vec dot back dot first. If I do these many steps, then it's like if I do only one more operation on the last sort, then if I do this, it means that I can only do one more operation on the last sort. So my value of n will be at most 2 times 10 to the power of 6. Because AIs are up to 10 to the power of 6. And if I keep doing it, if I find this C of I minus vec dot back dot first, I see that how much it is greater than A of K, and I divide it by A of K minus B of K, then my value of Ci will be that close to vec dot back dot first, so that only one additional operation makes it less than that. So it means that this is now less than or equal to 2 times 10 to the power of 6. So I can then just simply add dp of Ci to ans. And that's going to be all. Does it make sense now? Or do you need any additional explanation? Again, please use this emoji if it makes sense. Shall we move on to problem E? Can we do without dp? I don't think so. No, I don't think so. Maybe there's a solution, but I can think of that without dp. I think The author had a point when he has set ai up to 10 to the power of 6, but ci up to 10 to the power of 9. It wants us to make ci is less than the last value of a, and then do something in range 10 to the power of 6. And with high probability, he expects us to use dp there. Thank you. Okay, let's move on to problem E then, I guess. Okay. So, problem E, distance to difference. Okay. This problem says that we have an array A of n integers where every element is from 1 to k, and every integer from 1 to k appears at least once. Let the array B be constructed as follows. It is the distance to the closest number that is not equal to this one, and then you need to find the number of different arrays B you can obtain if you consider all possible arrays A, and print it modulo this. So we want to find the number of different array B's that we can have if it starts from this A. If for any of A, and A should have at least one of every numbers from 1 to k. Okay. So in this one, I can just say that first of all, I can make any block of any size if I want. For example, let's consider that the first number is, for example, number 1. I can make any block of any size with ones. For example, if I want to have only one 1, then there will be a 1 in here. If I want to have 2 1s, then there will be a 2 here and a 1 here. If I want to have 3 1s, then there will be 3 2 1. If I want to have 4 1s, then there will be a 4 3 2 1, and so on. Also, about the elements in the middle, for example, assume that in here I want to have a block. Anything can, any size, it can have any size. If its size is 1, then it consists of only a single 1. If its size is 2, it consists of 2 1s. If its size is 3, it consists of 1 2 1. If its size is 4, it consists of 1 2 2 1. If its size is 5, it consists of 1 2 3 2 1, and so on. So what I'm saying is that you can make a block of any size if from any number. So it gives us some intuition about having some dp of I, and dp of I can go to any dp of j less than I, because I can make a consecutive I can make an interval in a size that I want, in any size that I want. It is problem E. I'm discussing problem E. So I'm saying that each number can make a block as we want, and we know that in here that k is up to at most n. K is at most n. So what I can say is that I can have some dp of I and j which says what is the answer if I consider an interval, a suffix, let's say a suffix. Assume that dp of I and j says that if I consider a suffix of length I and I want to choose j numbers in there, I mean from those k numbers that I should use in A, I want to make sure that I have used j numbers. Okay, then how many ways do I have for array B in here? So dp of I and j means that if I consider a suffix of length I, if I consider suffix of length I, and I have used j numbers in A, j numbers in A, how many different B's can I have? How many different value of B can I have? Okay, so suffix of length I, and I have used j numbers in A. How many different value of B can I have? Well, how can I update this TP? Because as I said, we can use any interval of any size. Okay, I can have any interval of any size. So therefore, I can just say that dp of I and j gives me some intuition that it is going to be equal to the sum of all the dp's of L and j minus 1s such that L is less than I. Because I can just choose an interval, a prefix of this suffix, and I say that, okay, it uses a number and it will cover one number, and the length of this interval is this. There's always exactly one way to have an interval of that length. Okay, and then it's going to be equal to sum of dp of L and j minus 1. And this is almost correct. We only need to consider some corner case, but the whole idea is this. Because any interval can be counted only once, I mean, if you have an interval of length 5, then definitely your array B will look like 1, 2, 3, 2, 1. If it is of length 6, it will look like 1, 2, 3, 3, 2, 1. J numbers in A means that we have used J difference numbers, because we need to make sure that at the end all the K numbers will be used. All the K numbers should be used at the end. So J means that in A, what is the maximum number of different colors that we have covered? So J means that. Okay. J means how many numbers have we used in A. That's because we need to make sure that at the end K numbers will be used. Okay. So now I say that because this prefix can have any length, this block can have any length, any possible length, then it's simply equal to sum of dp of L and I, j minus 1. But there are some corner cases somehow. There are some special cases, I can say. Well, first of all, I should not consider when I'm solving these parts, because this is just an interval in the middle. It is not an interval in the beginning or in the end. It is not a prefix or a suffix. One thing that I can say is that my interval should not be of length 2. This is a very special case. The interval that I choose should not be of length 2. So L can be anything but I minus 2. Why I say that? Why I say that L, it should be the sum of dp of L and j minus 1 for every L other than I minus 2. Because if I say that in my suffix there is a prefix of length 2, then it means that they are 1 and 1. If we have two consecutive ones, then having a block of size 2 is no difference than having two blocks of 1. So it's like instead of XX, they could also be XY and have the same array. This is only this special case that we have a block of size 2. When we have a block of size 2, it's completely like we have two blocks of size 1. So I can say that do not consider blocks of size 2. That will be counted in blocks of size 1. But for values greater than 2, there's only a unique way. Because for greater than 2, we have at least one element which is greater than 1. Everything will be uniquely determined. But for 2, 2 is very similar to A, so I should not consider 2. Only for my base case. Only for my base case, because that is a suffix of length 2, 2 is different to 1. Because if I have 2 equal elements at the end, they will look in B like 2, 1. Because to the right of them there is no element. So only in my base case I should consider that. Only in my base case, dp of, for example, I know that dp of 0 and 0 is 1. dp of 1 and 1 is 1. dp of 2 and 1 is 1. And dp of 2 and 2 is also 1. These are my base cases. In here, I consider the case that I have 2 equal elements right after each other. Because they are a suffix, and if they are equal, it is different than if they were different numbers. But in the middle, because they are not a prefix or they're not a suffix, length 2 has no difference with length 1. So I will not consider length 2. And that's all. I just need to consider this a special case. I should say that, where is it? I should say that L should be not equal to I minus 2. And then, if so, if for all the other values of L, I can just say that just sum up dp of L and j minus 1. And then my final answer is going to be, because I have solved for all the suffix, I do not consider the whole array. And I will tell you why. Because again, prefix is also different. Prefix and suffix have special cases. That's why I'm just considering the suffixes of length 0 to n minus 1. And then I consider that I'm adding one more block to the beginning of them. I consider that first block of numbers differently, separately, compared to the others. Assume that initially I have a block of size k. It means that the first number should be k, the second one should be k minus 1, and 2, 1. Then my answer is going to be, let's say instead of k we have x, because k is the number of different numbers we have. Our answer is going to be dp of n minus x and k minus 1, because in here we should have at least k1 minus 1 numbers. And there's one other thing that is important. If something becomes greater than k minus 1, you can assume that it is k minus 1. Or you can say that if it became greater than k, I mean, you can have a limit that you can say that, okay, I consider these many different numbers. K is up to 10. So for k equal to, for your maximum, you can just also update it from dp of all of the L's and J as well for your maximum. Maximum will be updated from dp of L and mx as well, itself as well, because mx is the only thing that goes to itself. That's the limit. It doesn't increase anymore. So anyway, you have some limits that your second dimension does not become greater than that. It goes to itself from some point. And then in here, you need to add dp of n minus x and k as well, if k is your limit. But you could also say that k minus 1 is the limit. Okay, so only k updates from itself, as well as being updated by k minus 1. But all of the other ones will be updated from the previous ones. So I fixed that. I have x, a block of x numbers at the beginning, and then I have n minus x numbers, and there should be k minus 1 difference numbers there, or k different numbers there. Is this clear? Shall we move on to the code? Please use this emoji again if it's clear. Okay, awesome. So let's move on to the code. Okay, in here, as I said, I define the DPs. I also save the sum of the DPs of the specific dimension, for the second dimension, because that is important for me, because I know I want to once sum of j is equal to dp of L and j's for all L's. Okay, so sum of 0 is initially 0. Sum of 1 is initially 2, because if the second dimension is 1, we have 2. Sum of 2 is 1. Then I start from 3, and I will go to n, and I have a 4j from k to 1, j minus minus, and I will tell you why this 4 is backwards. I say that dp of I and j initially is sum of j minus 1, because it should be the sum of dp of L and j minus 1 for all the previous L's. And why my 4 is backward? Because in sum of j minus 1, I do not want dp of I and j minus 1 to be included. I want all the values less than I will be included. So if it was forward, if this 4 was forward, dp of I and j minus 1 would be included in sum of j minus 1 as well. But when I do it backward, that one is not included. So if j was equal to k, I say that dp of I and j is equal to dp of I and j plus sum of j modulo mod. Because as I said, when j is equal to k, it means that it's the limit, it's the maximum. So it will be updated from itself as well. K goes to k. K does not go to k plus 1. Everything goes to plus 1, but k, because it's the limit, we don't go greater than k, goes to itself. And then I say that if I was greater than or equal to 2, which it is, because I start from 3. Initially in my code, I was not starting from 3, and that's why this if exists here. But afterwards, when I changed this to 3, I could remove this. If I is greater than or equal to 2, which is dp of I and j should be subtracted by dp of I minus 2 and j minus 1. As I said, because I should not consider 2, the case 2. And if j was equal to k, it should also be subtracted by dp of I minus 2 and j as well. It's similar to this one. For the special case of k, I should consider k itself as well. And then sum of j is equal to sum of j plus dp of I and j modulo mod. And then at the end, as I said, I set ans equal to 1. I consider the remaining parts. I consider that I have a prefix of length n minus I, consists of the first number, and there will be I numbers remaining to the right of it. I should add dp of I and k minus 1 and dp of I and k to ans, because in here I should either have k minus 1 different numbers, because 1 will be added to them. So I will have at most k numbers this way. So I will cover all the numbers. I mean, the best, I am able to cover all the k numbers. Also, if it is k, that's okay, because I have covered k, and in here I am still covering k. So everything is covered. So this is all about the code of problem E as well. Is it clear? If it's clear, we will move on to problem F. I haven't solved problem F myself in the contest, but we can discuss it. We will read the codes of people together. So if you want to move on to the next one, use this emoji again, please. I couldn't continue the contest till the end as well today. I had to leave the contest. I want to see if tourists accepted that, and yes, tourists accepted the problem. I remember that tourists had 3 wrongs at the time that I was leaving. Okay, so then let's move on to the next problem. Problem F. Simultaneous coloring. This problem says that you are given a matrix consisting of n rows and m columns. You can perform 2 types of actions on it. Paint the entire column in blue, paint the entire row in red. And you can perform either one action or multiple actions in the same time. The good point of doing multiple actions is that you can paint the shared ones as you want. now each time you are given a requirement and you have to say that what is going to be the minimum cost to color in that way. And if we use k of them, k rows and columns, we have to pay k2 points, k squared points. Okay, why my video is... Okay, so let's see how people have solved it. Let's see a code and try to understand it. It's too huge. Okay, so the code of this problem is huge. That's one thing that we know. It seems like they have used DSU. Okay, initially he has enumerated all the rows and all the columns, and then he has stored all the queries, and then okay, in this line, this is only for input. Okay, so in here, this is nothing, only inputs, and then solve one queries. We want to solve all the queries. If not of with of u is 1. And guys, if you had anything to say, you can also say in here if you had any idea about anything. Feel free to say that in here. They have used Tarjan. And divide and conquer. So the graph is, I think, between rows and columns, I guess, if I'm right. Yeah. Yes, so he has made a bipartite graph between the nodes in one part are the rows, in another part are columns, and an edge is added between a row and column if there is a query on that one. And the ID of it is just the ID of that query. Okay, and it is directed. If C is blue, it means that column should come after the row. If it is red, it means that row should come after the column. So this it's interesting. These directions show that what the order should be, and if we do not have any cycle, then the answer is definitely 0. Okay. If there are no cycles in that graph, the answer is definitely 0. This is interesting. And let's guess the answer. Maybe the answer is in each SCC you have to multiply the numbers in the left parts by the numbers in the right parts. Maybe that is the final answer. I mean, no, not multiplying. I mean, you should sum up the number of nodes in left part and right part and have it to the power of 2. Raise it to the power of 2. Yeah, I think that's it. That's this. Because otherwise I guess that's it. Yes, I think that at the end you should find all the SCCs, all the strongly connected components, and then see that how many nodes are to the left, how many nodes are to the right, and raise the sum of those to the power of 2. And then let's see what it's doing here. It's not easy. If id was less than or equal to me, okay. So in solve, this mid just means that which queries you're thinking about. Okay, you first try to solve it for the middle points. Okay, it's getting interesting. And then 4 out of u unknowns, if you have a Tarjan, if not dfn of v Tarjan of v, low of u is equal to minimum of low of u and low of v. If dfn of u is equal to low of u, the main idea in here seems like to be we are going to solve for the middle query. I think in here somewhere, event of mid.pushback id. So it stores. Okay. Okay, it seems like first it's in these events, he tries to save that. In this event, he tries to save that when we reach somewhere. Let me explain this from the beginning in a more structured word. I haven't understood all the details, but I understood the general idea that he's using. So from what I understood, the answer in here is that for this problem F, let me also explain the problem once again now that I want to tell you the solution. It's like each time we can choose a subset of, each time we can choose a row or a column or several rows and columns, and then we will make all the rows in the red, all the blues, paint all the columns into blue. And if there are several cells such that they are both in a column and in a row, we can paint that arbitrarily. Okay. So now in here, well, what is happening is that when a query arrives that says that these cells should be red now, what does it say? It's basically saying that row number I should be chosen in an operation after column number J. So if this is cell number I and J, when this cell should be red, it means that row number I should be chosen somewhere after column number J. So we can consider we have a bipartite graph. These are the rows, these are the columns, and we can add an edge from that column J to this row I. And with the same situation, if this is blue, if another one is blue, we can just say that there is an edge from that specific row to that specific column, meaning that that column should come after that row. And then if there are no cycles in this graph, everything is good, because we can just choose them one by one and just make sure that those row and columns that should come after the other ones really come after the other ones. If it is a DAG, that is possible. But when we have a cycle, there's no way that we can do that, and we have to have all of them together. When we have a cycle, we can easily show that the last operation that we do on one of the elements in that cycle, all that cycle should be in that operation. Okay, so the important thing that we say is that when we have a cycle, if we consider the last operation, that we use one of these nodes, one of the rows or columns that are in this cycle. If we use only one of them, we have to use all of them. Okay, we have to use all of them. I think a spammer has messaged. So if only all of them if one of them is in that, all of them should be. And so all the SCC should be there, because these are in a cycle, and again some of them are in another cycle as well. Some of them are in another cycle, and so on. So we have SCC, we can say that in the last operation that one of them will be there, all of them will be there. So if we consider all the SCCs that we have, if size of them is k, in total, the cost is gonna be sigma of ki squared. So we need to find out at each time what is the sigma of ki squared. And how do we calculate that? From what I understood from the code of this user, Phonics Rebirth, from what I understood is that he tries to keep some events, and in event of meet, he stores all the vertices that should be merged there. All the vertices that should be merged at that point. And he tries to each time, he has a function solve one q queries. Each time he fixes meet, and he tries to add all the edges till meet. And then he sees that what are the SCCs that we have, and for all the edges that are before it, and the SCCs are the same, in the events he will push that back, he will push back that edge, so that he knows that in here he can merge them. Okay, so in here he just wants to, in this solve, he just wants to prepare something that afterwards he will use DSU on them. In here he will just find out all those edges that he should later add in his DSU. So he will add edges in this mid event of mid, he will push back this ID so that he knows that he should push back, he should merge those two vertices there. And then using divide and conquer, he will continue doing this and find those edges, and at the end he will keep merging them till finding the final answer. And that's gonna be all. So I didn't go through details on this problem. I just tried to, as I said, I haven't solved this problem in the contest, and I didn't have, unfortunately, a chance to think a lot on this problem. But from what I understood from this code, I hope this makes some sense for you and it can help you. Is it clear? If it is clear for you, please again use this 100 emoji, and if not, tell me to explain any parts. That's it. Awesome. That is awesome. Any course you can suggest for CP? Well, right now I know USACO guide is good. I know CP algorithm has good things. And also I myself try to someday make a good course that can be useful, but I'm far away from that. There are many topics that I should cover. But for now, I think USACO guide, CP algorithms, they are good. Also, from the topics that I have covered, if you like, you can watch them. Okay guys, do you have any other questions or comments? When is the next CF contest? Well, the next contest is in 3 days. So I will see you then. Thank you very much for watching till the end. It was so nice to have you again here. See you next time. Bye bye.